Hi everyone, good morning. Welcome to my new series. So this is going to be one of a new series. So the beginner series where we were just installing that how we can run. So we were just exploring how we can run AI models with ServiceNow and what different types of models we can run. So we saw that computer vision models can be run, uh, and LLMs can be done. Local LLMs can run. Machine learning models which have been created on ServiceNow data can run. So all those things were there. Now what I wanted to, so this new series is about building a full-fledged application via AI and ServiceNow. So I'll start with something which is very common, and uh, and this use case, but I will invite more use cases. So if you have any suggestions, please give it to me. I will try to incorporate those. But this is something that I have created for the first use case. Now, this use case is very simple. So we have seen that all companies is plagued with attrition. Sometimes the attrition is basically employees resigning or layoffs, all those things. So mostly related to resigning. And so when we are, as a company, when we are planning for like long-term project and employee may have like different uh, uh, like commitments or something comes up in their life or so as a company, we want to understand what will be the survival timeline for that employee. And in machine learning, we call it survival analysis. Now, the survival analysis is nothing to do with the survivor. Employee will be full-fledged surviving and thriving even. It has only to do how long they are going to stay in the company. And for that, um, how what I have created and how we can use that information means existing. And so we all know as ServiceNow is being used for human resource service delivery like way too much. So there are too many implementation for that. And this use case can be very useful for those who are so for the HRs who want to understand uh, in from the long-term perspective, or the practice leaders who want to understand how many of their workforce, suppose a workforce, there's a company which has a workforce of 100 people, and based on this analysis, if they can understand that like half of their workforce is going to resign by 5 years, then it's good to have buffer. Obviously, we cannot. We will have a confidence level of to determine that okay, this is the amount which this is the confidence level of this analysis, and it will be based on the past data. So without further ado, let's just dive into. First, I will show the workflow, what I have done, and then I will go one by one in each section. So the whole workflow is divided into 4 parts, as you can see. One is related to ServiceNow, another is the local server, or if you have a Docker or a container where you want to, so basically I wanted to create an API. So the model that, so I got this data. So this is a IBM synthetic HR data, and it has different attributes which can be readily available in any organization. I will show the data. Okay. So now that data, and so ideally what we will do is we should have this information in our HR profile. Okay. Or HR related information. Okay. So it should be connected from here, but right now means I don't have that any. So I used IBM synthetic HR data, and then I built the model in Kaggle, and I wanted to do a little bit of EDA because it is important to understand what type of information we have and what we want to, how we want to use it, right? So third part was, so once we have the model, now I want to use the model as a microservice or an API, whatever you want to call it. So I used a Docker and FastAPI to do that because it is easier. So you just create an image and then put it. I will provide the code for each one of them. So if you just want to just plug and play, that will be also fine. And then lastly, use ServiceNow to call the data and get the information. Okay. So starting from the first, let's check the data. Okay. So I will directly show the information in the Kaggle. And this is a Kaggle notebook that I've created. It will be available as well in the description. So, and I will quickly go through it. Okay. Remove this and this. Okay. So first thing is this database. So if I'll go to Kaggle, so you can see this is the data that I've loaded from. This is directly coming from Hugging Face. And once you load the data, you can see. So here are the different attributes related to the data. So age, attrition means are they available or not? Like are they already resigned or not? Let's just, yeah, here. Age, attrition, business travel, daily rate, department, distance from home, education, employee count, employee number, gender, hourly rate, job involvement, job level, job satisfaction, marital status. So as you can see, there is a lot of information related to employees given. And if your HR profile doesn't have this much information, that is fine. What normally people do is, so just give me a second. Just plug in. Okay, so what normally people do means you have already seen that satisfaction surveys are very crucial part of HR job, and this provides like a satisfaction survey can provide most of these information, like where you live and distance. So we can identify how far is your house, and you will understand from the data itself that how it is relevant, and we will find how many of this data. So more data you are getting, more is important, you know. So let's see. So this is some data that is fine. And here what I've done, now I'm doing a correlation. So correlation as in between each points, I wanted to understand which of the data is more like closely related, you know. So let's see, so this is no, this is not the correlation plot. This is showing what are the different information we have based on like we have data till 60 of age, and how many so we can see the median age is lying around 35. Most of the employees are related 35, and the daily rate is consistent. Total working hours is also median around 10. So this gives you light of a kind of a overview of your employee data. Okay. Now, so again, this is categorical feature, like how many of them do business travel, how many do not, what are the different departments that we are considering. So we are considering only 3 departments: sales, research, and human resource. And what are the different job roles that people have, so all those things. Now this is the correlation plot. Correlation is very important. It gives you like years with current manager, how much this is years in current role. So these 2 points are very much correlated. So again, you don't have to do this. I'm just giving you a little bit of information to understand how much, what different data that we have. Now, the important part is we wanted to understand, create a model, right? So I used multiple, I created multiple model. There's Kaplan. So this is a survival analysis. Now, survival analysis, how this works, it basically provides kind of this, like over the years, what are the probability of your employee to survive? So 0, it's 1. But as you go on, like 10 means by 30, it has become half. So if an employee is going to be for 32 years in your company, half of the employee by 32 years in your company is going to leave, which is pretty good, And we don't have data after 40. That's why it is like a sudden drop over there. But that is, so this is a Kaplan model. But what we wanted was Cox model. Mostly people use Cox model. And it is also giving us like more accuracy. And this is what I have created. So again, you don't have to, just explaining a little bit about it, just to understand what I have done to create this model. Once you provide all this information, what you want, what is the duration, what is the event, and the Cox model will get generated immediately. And then I'm storing the model. Once I have stored the model, now I want to do prediction. So prediction, I'm using some data information from the data frame. And I wanted to see what is the survival rate. So as you can see, the survival is coming, means this is the predictor survival. And it is giving us a list of numbers. Now, list of numbers is not very intuitive. So what we do, we will visualize it on this plot. So as you can see in the plot, so this is the survival probability. So the employee whose age is 41, and these are the different parameters, like percent salary hike was 19, education was 4, and distance from home was 2. So he is going to survive for 33 years, which is pretty good. So there are certain events that can happen over here, but still the probability of survival is pretty high. But in 32, it's pretty low, So we can, so that is fine. So now what I have to do, I just have to download this model. So I have created a model file, which is in pickle format, and then I will store it. Once I have stored it, so let's go for the next one. So I got the data, created a model, stored the model. Now the model is there. The model is in my local machine. So this is my local machine. What I have to do is I have to create a FastAPI, means a Docker image basically of the FastAPI, so that it can be used as a microservice or an API call. So I've installed Docker over here. And as you can see, the API is already running, but I will show what I have done for this. So this is my employee attrition file. And now this contains two files. One is the app file. This file is what converting my model into FastAPI. So as you can see, this FastAPI, I'm using FastAPI. So FastAPI is nothing but a way to, so I will show it over here. Now, FastAPI gives provide you kind of your local server where you can directly call. And once you call /predict, it will call this function, definition predict. And this predict definition will call, so yeah, it is calling your attribution prediction model dot predict. And this predict model is available over here, okay? And what it is doing, it is simply calling model predict survival function. And here, as you can see, I'm using the model, which is a Cox model. So this pickle that is I stored, which is I stored from Kaggle. Now, so here I'm giving all the input and sending it to /predict as a request. And this request is calling the model and then providing the prediction. So simple. That is all it is doing. So now let's check how it is working. So if I will create a request, So here is a request. Now, this is how you can request from anywhere. I am doing it from the local machine. We can do it directly from ServiceNow. Either way, it will work the same way. But if you are doing it from ServiceNow, we will need to use mid server because my server is running on localhost. So as you can see, I have a Docker file over here. Docker file provides nothing, but it's a kind of instruction that we have to provide, like what is the model path and uh, what so all the information, so all the libraries that I'm using for my model to run, that needs to be present in the requirement.txt. That way, it will first install that requirement in a container, then run that on this particular port. Okay. So once you have that information available and it is running, so you can check if it is running or not. So here you can see, yeah, here my Docker is running fine, and you can also confirm it from here if the container HR iteration API on this port is running fine, and it is running from past 3 hours. Okay, and this is my image, which contains all the information related to what it has done over here. Now, once you have that information, you can simply call it from ServiceNow or any other. I mean, if you're calling from ServiceNow, then you have to do what you have to do is sorry, it got yeah, it happens sometimes. So because something is running for so long, my RAM is like, so now to create a request, so simply I have and you can directly call this API. So I have shown what is the way to call. So here, if you have a HR UI and HR queries when employee 2 is likely to resign, so you have to simply provide that information. Now, what information we need is the request need, and it will create a request that needs to be sent to the mid server. So this is the information that you need to send. So like age is 32, education is 2, person salary hike is 2, only working years is 8. So whatever information, and then like he's in department, sale department, and gender is male. And let's see what is the survival rate for this person. So if I'll just simply run it. Yeah. So here you can see, so I have provided more of a visualization, as I said. You can provide the information in any way. So, but once you run, you saw that, okay, the survival probability decreased, means this person who is in sales and has age 32 is going to be with the company only till 11 years, which is kind of very important to understand because if you are planning a like long-term project with this person, or something has not changed in his profile, like the height has not changed over the years, means the trend. If you are following the same trend, then this is what is going to happen. If you are going to change the trend, like suppose you gave like very high, good height, then maybe means the data you will need to run this again, because trend is what is important. Now we can check if age is something that matters. So 49 and is 6, so say it. And if I'll choose it that he is in department research, and he is in, let's say, life sciences field, and he's a research scientist, not a sales representative. Total working years has increased to, let's say, 20, and Control S, and let's see. Yeah. So it is running. Let's just oh, okay. So this person is never going to leave. Super loyal. Um, and the profile is something. So he's a research scientist. Age is 49. Because the age was already too much. I believe that may have caused it. And let me just decrease the working years as well. 32. Let's save it. Okay. Let's try this. Maybe research scientist profile has a loyal employee base. Anything can happen. Okay. Um, just to remove this. Okay. It is running, I guess. Yeah, my system is super slow. Okay, so I think it has something to do with the research profile because, yep, they are super loyal. So, but again, this is a synthetic information. When you will have your correct information, and then this information, I mean, so this model can be very accurate as per your need. Okay. And this is what I wanted to show, that how you can build like a real-time use case where HR can do a very good analysis of your system, means of your HR data. And ServiceNow has a holy grail of means all the requests that are going in HR is kind of related to the employee profile. So you have kind of information related to most of the things which are going over there. And once you provide and create a model for this, simply call it. That's it. And you can like post it in cloud or anywhere. It is up to you how you want to use it. But I believe that can be very beneficial when they are planning future planning for your practice or your organization. Thank you, everyone. Hope you liked the